and today I'm going to be talking about Shade agents, the first truly autonomous, non-custodial multi-chain agents. You can find out more about Shade agents at near.ai/shade. So if we look at the state of agents, basically in the Web 2 space, we obviously have seen some really interesting things happen recently with OpenAI's Operator. And there's a lot of hype just in general around agents in the Web 2 space. It's pretty frothy and crazy in traditional tech world, as well as in Web 3. So we've seen a lot of agentic frameworks that have launched in crypto. And we've also seen some really amazing agents for things like Signal and also just entertainment value and digital twinning. But we did see some pain points with how these agents are launched, and three specific ones were decentralized key management. So basically, a lot of agents are run in trusted execution environments today, but the keys are not really sort of well managed. They're either kind of held by the developers, and in the trusted execution environment, if it goes offline, maybe the key's lost, or it's just a kind of an insecure way to manage keys inside a T itself. And then also there's the problem with full code verifiability. So how do we know that the agent that's running this code is actually running the code that it says it is? Things like basically upgrade processes and stuff for the agent code. It's all kind of a little bit loose these days. Like, we're not really sure what these agents are running, and there's no real kind of verifiability there. And also, we feel that these agents are lacking smart contract guardrails. So basically, that final step of sort of protection of, for example, like user deposits before some action can sort of be taken with them. So we set out with a mission to basically enable the building of truly autonomous agents for everyone. So we built the Shade agent stack. And basically, if we look at the top layer of the stack here, we have worker agent code. So this is any arbitrary code running inside a trusted execution environment. So this worker agent code can contact Web 2 APIs, storage, compute, and then it can bring that back into the trusted execution environment where it's running verifiable code. It can also run LLMs, or it could talk to LLMs outside of the trusted execution environment. It can really do kind of like anything that you can think of. Where this is interesting, though, is that the worker agent is tightly coupled with the smart contract layer that you see at the bottom in the Shade agent stack. And the worker agent basically gets its remote attestation from the trusted execution environment, which basically tells the smart contract that it's running inside a T. But it also gets the code hash of this arbitrary code that it's running. So the developer says, hey, I've got a worker agent here with this particular code, and it runs with this code hash. And then the worker agent registers in the smart contract one time and basically says, I'm running inside a T. Smart contract checks that, verifies it, and then also registered with that particular code hash. Any subsequent calls from the worker agent to the smart contract are basically already pre-verified, and we can do method access control in the smart contracts based on that code hash. So this is a very interesting kind of part of the Shade agent stack, and it opens up a whole new design space. So as I mentioned before, in current T implementations, we've got the keys maybe managed inside the T. If the T goes offline, or if there's some sort of new code pushed or whatever, this is a really insecure process. And basically, we could lose the connection to the protocol and to the user's funds, and all sorts of things could go wrong. So what we did was we basically made it so that worker agents don't need to manage keys, and basically the worker agent could just go offline, and anyone could boot up a new instance of the worker agent, provided that they're running the exact same code and still get access to the smart contract and the various methods that manage those keys. So that's a key differentiator there, pun intended. So this is the registration process for the worker agent code on the left and the smart contract on the right, and how you would kind of go all the way through to basically making on-chain transactions. It's a little bit much to go over, but you can check this out at near.ai/shade. So we've deployed these Shade agents already live on Fala Cloud. So we've used them as kind of like a partner for our first Shade agent template. And all you really need to do is just deploy some Docker YAML, and basically you're up and you're going with your first Shade agent. in the worker agent code, so in this like arbitrary kind of, this is JavaScript, but we also have one that's coming out for the shade agent template in Python as well. There's really just a small amount of code for that agent to basically create their own account that can call the smart contract. And we create this account with the T's hardware entropy. And as I mentioned before, the big kind of differentiator here is that we grab the code hash from the T's hardware and we basically pass that through to the smart contract register method. Now this creates a really tight coupling between the code that the worker agent's running and the smart contract. So we can do interesting things like method access control. So here we have a bunch of worker agent instances. We can have many worker agents that all have access to a particular method in a smart contract by virtue of them running that specific code that we want them to run. We can also have different worker agents operating on different pieces of a protocol. So we can have worker agent A and worker agent B operating on different parts of a smart contract, which is really cool. We can do this like method access control. So what can you build with shade agents? Well, as we mentioned, it's the first truly autonomous agents. And in the meme token space, I know it's like super hype and frothy and stuff. I like to think of it like we see a lot of agents that are launching with a token. But what does that mean? You got some agent and then you got a token. But where's like the real relationship between them? Like where's the tight coupling between that token's value, supply, or how the token's being managed, and like basically how the ecosystem is being managed around the token? How is that actually connected to the agent? So I like to think of shade agents as the first way that you can actually launch an agent where the agent is the token. So the agent code that's running inside the trusted execution environment, talking to LLMs and maybe doing stuff out on X and stuff like that, and posting, that agent is actually fully tightly connected to the token. And I'll show you an example of that in just a sec. Truly autonomous agents can also deposit and withdraw on any chain by virtue of using Near's chain signatures. So we can do things across any chain. I'll also show you an example of that in a sec. And we can also handle sensitive user data. Because we're working inside T's, which is a confidential computing environment, we can do things like Web 2 payments. As far as DeFi infrastructure is concerned, for things like oracles, we could do things like remove humans in the loop for upgrade processes and conflict resolution. For web markets, I mentioned a T can access any Web 2 APIs, so we can really just kind of create markets for anything. And the last concept, I like to think of it's like the hottest wallet. So basically, because we're inside a T that can talk to Web 2 APIs for like auth and other things, we can really create these like chain signature wallets that can access deposits and stuff on any chain with near chain signatures, but we can tightly couple that with like an x.com authentication as well. So we can basically have users just log in with X and go directly to this hot wallet. So as an example agent, we used our shade agent template, and just in a couple of days, we launched this shade agent 007. And I'll tell you what it does in a sec. It's just for fun. So we basically launched this agent that will basically read tweets on X, and it'll basically look for terms matching shade agents or AI slop. And if the sentiment is positive, it'll reward you with base tokens on Hyperliquid. Or if the sentiment is negative, it'll reward you with shade tokens. And this is live on Near mainnet and Hyperliquid mainnet. And we just slapped it together in a couple of days. So how this works is basically the worker agent code goes out and kind of reads the tweet. It analyzes it for the sentiment, decides which tokens it's going to give the user. And then it creates an EVM transaction. And then because the worker agent is running that particular code hash, it's registered in the smart contract. And it will basically go and ask for a signature to broadcast on the Hyperliquid mainnet from the smart contract. And because it runs that code hash, it will be given the signature, and then that transaction can be broadcast. So yeah, this is running today. It's pretty exciting stuff. And yeah, just kind of check out shade agents in general. And again, I just want to hammer home this point of method access control. This is really like the tight coupling between worker agent code, like what is an agent actually doing? What is the brain of an agent actually doing? And like how is it kind of like behaving and responding to things? And the actual on-chain transactions or like parts of the smart contract protocol. So thanks for checking out Shade Agents. And once again, you can find out more at near.ai/shade.